There we go. Okay. So good morning, everyone. Thank you so much for coming to this workshop on energy modeling. My name is Jess Hoover, and I am the Climate Action Director for the High Country Conservation Center. If you're not familiar with us, we are a resource conservation nonprofit here in Summit County, and we have been very involved in supporting the community's new sustainable building codes. And one way that we do that is by hosting workshops like this one. So in addition to today, we've scheduled 2 more workshops this winter. On February 3rd, we'll be discussing HRVs and ERVs, and on March 30th, we'll be offering a deep dive into continuous insulation. So if you're interested in either of those workshops but haven't signed up yet, I'm gonna just quick pop the link to the registration in the chat right there, so you can register on that using that form. I will say that the February 3rd workshop, although it says it's in person on the registration form, most likely will be another virtual workshop. Hopefully by the time the end of March rolls around, our case incidence of COVID up here in Summit County goes down and we can get together in person again. Would love to hear from you about other topics you'd like to learn more about. So in addition to HRVs and continuous insulation, what building science questions do you have? What building questions do you have? Let us know, and we are happy to host additional workshops that cater to the challenges that you're having. So you're always welcome to shoot me an email to let me know what you would like to learn more about. And I'm going to pop my email in the chat too. So like I said, please feel free to reach out. I am going to send a recording of this webinar out afterwards, and Scott is going to share his slides, so you will have access to those. If you have any issues with sound during the webinar, please let me know by using the chat function. And then we do want to hear from you, of course. We've left plenty of time for Q&A. So there's also a Q&A bubble at the bottom of your screen. So you can pop your questions in the Q&A or the chat, either one works, and I will help Scott with questions as they come up, or we'll answer them at the end. And I think that is it that I have for housekeeping. So our presenter today is Scott Doyle, and Scott works for RESNET, which is the overseeing body of the HERZ rating system, which many of you might be familiar with if you are working on any zero energy ready home projects. And so he is here to talk to us today about energy modeling. So with that, thank you again for being here, and take it away, Scott.
All right, thank you, Jess, and good afternoon, everyone. Or actually, it's still morning for us here. And welcome. So the webinar today is going to focus on what builders need to know about energy modeling as it applies in particular to your building code in Summit County. As Jess said, my name is Scott Doyle. My title is Technical Director of Quality Assurance and Training for RESNET. I happen to live and work here in Colorado. I'm down in Loveland. Spend basically every spare moment that I have going west up into the mountains, and just love living here in this state. I worked for many years down here on the Front Range with builders all the way from Colorado Springs and up to Cheyenne. So I have a background basically working with builder clients, and about 4 or 5 years ago, I made the change to working for the national nonprofit that governs the energy rating industry. And so I'm going to be speaking to you mostly about energy modeling, and hopefully we'll demystify some of that sort of black box feeling that you might have about, how do the scores turn out the way they turn out? Why do certain upgrades or changes to my energy specs make certain changes to the outputs that the software gives me? Again, if you have questions, my email will be at the end of this presentation, and we will be sending out, Jess will be sending out a PDF of these slides. So here's our agenda for the day. I'm going to cover a little bit of background about what RESNET is, what the HERZ Index is, the people who you would hire to do these services for you, HERZ raters. But we're going to spend most of our time on the rating process, and those last two bullet points, I'm going to go through an example HERZ rating model, kind of show you a high level step by step of what the rater is actually doing when they create an energy model. And then we'll take a look at some of the outputs from the software once you've completed it. And that would oftentimes be the energy rater's deliverable to their builder client. So RESNET is an industry-based 501c3 nonprofit. We were founded in 1995 as a national standards making body for the building energy efficiency rating and certification systems. This really kind of came out of a collaboration between the mortgage industry representatives and the state energy offices of a handful of different states that were all kind of trying to sort of do their own version of an energy rating system to have a means of comparing homes and talking about the energy efficiency of residential structures. And there was not a national effort in the early days, and so this collaboration that created RESNET was intended to make this essentially a national way of evaluating and talking about the energy efficiency of residential buildings. These days, we spend a lot of time working in standards. We set the standards for certification of home energy raters, the quality assurance of their work, and on the rating system and how the modeling software is supposed to work, as we'll see here in just a few minutes. The HERZ Index is our primary, I guess, bread and butter, if you will. It's a rating index that describes the energy efficiency of a home. If you're not familiar with the score, lower is better. It's kind of like golf. 100 is the baseline score, so each point below 100 represents 1%, I should say, efficiency change. So that 100 benchmark home is a home that is built to the 2006 IECC. So it's kind of a middle of the road if you think about the housing stock across the US, particularly in the East Coast, where you've got housing stock that is 200 or 300 years old in some cases. And so a home built to the 2006 IECC doesn't seem very good for those of you that are building new homes today, but it does represent kind of a middle of the road efficiency when you think about the national housing stock. This is an important slide, and I'll come back to it later on because it's kind of the basis of what we're going to talk about today. The home energy rating scoring system is really based on this comparison between the home that we're going to build or have built in the case of an existing home as a comparison to this reference home. So the software is making the comparison for us, and I'll be going through kind of a detailed step-by-step about how the energy rater describes the characteristics of the rated home. And then what you'll have to understand is that the rater is not necessarily building the reference home separately, which you might do in commercial modeling, where you kind of have to look up through books, if my actual building has these characteristics, then what should my reference building have? And in commercial modeling, there's a lot more manual work. Historically, there has been a lot more manual work to create a reference building. And the nice thing for energy raters is that through RESNET's standards, the software that we accredit has to create a reference home using a standard set of rules that are based on the characteristics of the rated home. So we'll go through some of those things so you have a better understanding of what the reference home characteristics would be. And that has a lot to do with then why do you compare favorably or less favorably depending on what energy specs you might choose. HERZ ratings could be done on new homes or existing homes. Most of the ratings actually historically have been done on new homes. But there are areas where state or utility program incentives have been put in place to get a rating on an existing home. And in fact, the original concept, the reason the mortgage industry came to the table in the first place was their vision was that HERZ ratings would get done on existing homes for the purpose of incorporating energy efficiency into the loan and being able to lend people more money because their month-to-month bills will be lower due to the energy upgrades, and perhaps give people a means to finance energy upgrades on older houses. But as it turns out, that most of the use in the last 20 years or so has been on the new home side. In 2021, RESNET surpassed 3 million rated homes. So it was a significant milestone, especially because the second million homes, we reached twice as fast as the first million, and that rate seemed to have really picked up. We got to 3 million homes in just a few years, where it took the first million homes like a decade to get there. So you really feel like this has gained quite a bit of traction in the marketplace. This was based on some statistics from 2017. We don't have a new study yet to put up here, but just to give you a sense of which homes are getting rated across the United States, it's pretty heavily tilted in single family. And since this study was done, those average HERZ Index scores have come down a bit. As you might expect, energy codes have become increasingly vigorous, and that is basically driving the need for more and more efficient homes. So the average HERZ Index score, which is mostly done on new homes, is being driven down from those averages listed there. This is nationwide. And I would say probably as a trend, multifamily has come up a little bit higher as a percentage of the total rated homes year to year. This is also from a study that's a few years old now, that was done by Dave Roberts of the National Renewable Energy Laboratory in Golden. And that broke down the percentage of all new homes that were being HERZ rated. And again, we've seen some of these percentages climbing up here in our state. In Colorado, 38% was the number they came up with at the time. This is based on the number of ratings that were submitted for Colorado compared to the total number of permitted homes in Colorado at that time. And I think we're probably creeping closer to 50% these days. I won't spend too much time. I'm not here to necessarily sell you on this, but we've got plenty of these kinds of materials if anybody's interested in it. Getting some idea of what you might want to use to talk to consumers if you've got homeowners that are interested in understanding what the HERZ Index is and what the benefits of having their home rated or participating in Zero Energy Ready Home program. You can reach out to me for some of those things. To become a HERZ rater, there's a few different requirements. It says 40 hours here, but it's typically, these days, it's not often that folks attend a live course that's 8 hours a day. It's more likely that folks are doing some kind of blended remote learning, which is really what most working adults would do if they're going to take any kind of professional certification. It's oftentimes happening remotely, and that means it could be on their own time. It could be spaced out over 6 months, or they could kind of take it all at once. But I would say most people are probably investing 60 to 80 hours into that course overall when you account for their study time, etc. Raters have professional development requirements to maintain certification. They've got multiple tests to pass before they can become certified. There's kind of an apprenticeship to it, where they do some probationary ratings that are evaluations of homes that are supervised by a quality assurance entity that oversees their work at the start when they first get certified, and continues to oversee a percentage of their work across the rest of their career. So that's a big piece of what we're doing in our rating system, is having a quality assurance oversight so that there's some third-party credibility to what we do, because our stakeholders are everyone from the EPA's Energy Star program or DOE Zero Energy Homes Ready program to utility programs, lenders, and the IECC even. So we've got quite a few stakeholders that we want to make sure they feel like they can trust the work of the energy raters in our quality assurance program, which is where I spend most of my workday, is a big piece of the foundation for us establishing that credibility. So HERZ raters can do a variety of things. They're qualified to conduct energy efficiency plan reviews, building envelope leakage testing, duct leakage testing, pre-drywall inspections, full verification of compliance with the ERI path within the IECC, which we'll touch on in a little bit here. And they can conduct energy modeling to determine HERZ Index score. And then a number of different programs like Energy Star and Zero Energy Ready will use energy raters as the verifiers to determine compliance with their specifications, which are over and above the things you might evaluate for a HERZ rating. And similarly, the IECC recognizes energy raters in many, this is usually up to the local CBO, but energy raters are the most often recognized as the third-party inspectors for IECC energy code. A lot of the energy raters obtain the plans examiner certification from IECC as part of that work. So now we'll turn our attention a little bit more to how you're determining compliance. And I'll give you some examples. The ERI is one path through the code, and there's a number of other building codes and utility programs that use the energy rating. So you guys are operating actually even above any of these, but the 2015 and 2018 IECC contained an energy rating index compliance path, which basically allowed builders to select that path and essentially obtain an energy rating index score to show compliance versus following the prescriptive list that they might have used in years prior. And so you're kind of there, and then beyond is really where Summit County is at this stage. Although that ERI concept is the same in both of those codes, they do describe it differently. In the 2015, they were using some generic language that basically set an index scale where 1 point equals 1% difference in energy use. They intentionally did that because we didn't have a national standard. RESNET didn't, that they could reference. So RESNET became an ANSI standard writing body in order to have our standards be nationally recognized rather than proprietary standards that we'd been putting out previous to that. So now ANSI RESNET IECC standard 301 is a reference that's right there in their code, and that describes a lot of what the software is supposed to do in terms of its calculations for creating an energy rating index score. That's just a generic term for an index score that we call HERZ Index. So one of the most important elements to that path is that it's the only energy compliance option that required verification by an approved third party. So that was kind of a big change, and something that you're seeing as well, that all of a sudden you have to hire this third party to help you navigate the compliance for energy code. So I don't want to focus too much on these. I know you guys have moved beyond them, but just worth noting that energy raters actually got involved in code quite a bit earlier, even as early as the 2003 IECC, I think, where there was some blower door testing, and eventually blower door testing and duct testing have become mandatory. And so even if jurisdictions are not using the full energy model and all those things, they're at least probably involving a third party just for those two tests, envelope and duct testing. So an often overlooked reason for the popularity of the HERZ Index, the many national, regional, and utility programs that use HERZ Index as their incentive, or at least the basis for their energy efficiency provisions. If they have a green building program, maybe that goes beyond energy efficiency, it might include indoor air quality, or in the case of LEED for homes, any number of other things like light pollution, or where you get your materials, whether they're recyclable, whether they're sustainable. I've highlighted the Zero Energy Ready Home program because that's the national program that Summit County has decided to recognize as a code path, and that's really has to do with your climate action goals. Lead for Homes is another one that is an example that uses, LEED goes well beyond just energy, but the energy component of it, instead of reinventing the wheel, they're just recognizing RESNET's HERZ Index. They determine, a target HERZ Index score. They have you add Energy Star on top of it, and that's the basis of the energy requirement within Lead for Homes, and then they layer a bunch of other sustainability requirements on top of that. So that's kind of the background of RESNET and the HERZ Index score, and now we're going to spend a little bit more time on the actual rating process before we get into the details of how you would do an energy model. So typically an energy rating on a new home happens in these three phases. Before the home is built, the energy rater would do a projected rating based on plans, and sometimes the energy specifications are listed on the plans by the architect, and sometimes they may need to do some consulting with the builder about what their insulation package is, what mechanical systems they are planning to put in, perhaps even advise them on upgrades to the energy specifications that would help them achieve their targeted goals. And at this stage, you can provide a projected HERZ Index score based on the anticipated design. And then if necessary, you can make changes to it, revise that projected rating. And in a lot of cases, this is something that gets used at the permitting stage, where that projected rating reports that come out of there are submitted with the package that you go in for your building permit. And then once the home is actually under construction, the energy rater would at least make 2 additional inspections. Sometimes it's more, but at the very least, they would need to do a pre-drywall inspection so they can see insulation before it gets covered up with drywall. And they're grading the quality of the installation, as well as looking at the building assemblies, what materials make those up so they can describe them in the software correctly. They're looking for air sealing details, things they could point out to make air sealing improved, because if you wait until final to think about air sealing, then it's a little too late, because things are covered up by drywall that probably contribute to good air tightness. At this stage, as a rater, you can evaluate the windows, because the NFRC labeling is still there. Cleaning crew hasn't stripped those things off. And oftentimes HVAC equipment has been installed, and you can at least do some preliminary data gathering on that. And then the second field test is typically, or field inspection is at final, when the home is substantially completed. Maybe it's not all the way completed. You might have some finishing trades in at the same time, but typically this is pretty close to the end of construction. Ideally, you want to have the whole building as airtight as it's going to get, so you don't want to have the vent missing perhaps from your kitchen range, or drywall penetrations not closed up and things like that. At this stage, the rater is typically doing duct tightness testing. They may also have done it pre-drywall if the distribution system is all the way completed at that stage. And they're evaluating some other features that get installed at final. For example, attic insulation. If it's like loose blown insulation that rests on the drywall plane of the ceiling, that wouldn't have been there at pre-drywall, and so they're going to go up into the attic and look at it at final. Appliances and other things, the thermostat that weren't installed at pre-drywall will be inspected. And essentially what the rater is doing at these 2 phases is just verifying that the design and the specifications that were anticipated at the projected rating, that those in fact are the things that got installed in the home. Sometimes there's a necessity to make changes, and the rater will then go into their original projected rating, and they'll make changes to reflect the as-built home, and that's what becomes their final confirmed HERZ rating. RESNET accredits the software tools that raters are allowed to use for the purpose of doing energy modeling and calculating a HERZ Index score. These are the three tools that we accredit today. I'm going to be focusing, or at least showing examples from Ecotrope. The one on the bottom left here is probably the most commonly used in your area. So here are the steps for the energy modeling process that we're going to go through. I've kind of broken these into chunks. One of the primary things is the rater needs to be able to describe the building assemblies that make up the thermal boundary, or the boundary between inside and outside conditions. So we're not describing every single building assembly. Interior partition walls, there's no energy to model across that boundary between one bedroom and another, for example. But the boundary between my inside and the outside, so that would be garage common wall, or an attic knee wall, or an exterior wall, those we need to describe, as well as floors, ceilings, slab foundation. Those kinds of things are the boundaries between inside conditions and outside conditions. And the software needs descriptions of those dimensions in order to model the heat loss or heat flux in one direction or the other, depending on your season. So the software is going to have a bunch of built-in weather data. It's going to do an hourly model of the energy transfer across all of these building assemblies that we've described. The second chunk that I've broken out here is describing the mechanical systems for the home. That's going to include their distribution systems, so space heating and cooling, as well as the ducts if it's air distribution, domestic hot water and its distribution system, and then whole house mechanical ventilation. So there's quite a bit inside those that we're modeling, including the duct leakage values that based on our tests, or in the case of a projected rating, you don't have a real test done, so you're going to basically put in a test value that is sort of a placeholder. A rater, it'd be reasonable to use sort of the minimum allowable to pass code, or in this case, zero energy ready in your case in Summit County. And then the last chunk that I've broken out for energy modeling is sort of the additional rated features, the other things that the HERZ Index score accounts for. And this is an asset rating, by the way, so these are things that would be typically associated with the home as an asset, and not the way an individual homeowner is using it. So as an example, when it comes to lighting, we consider the things that are fixtures and attached to the home. We don't consider plug-in lighting and lamps that would leave, with this homeowner when they sell their home. Major kitchen appliances and laundry appliances are considered to be things that often are left with the home as the asset, and so those can be considered if they're installed at the time that the rater is evaluating the home. And then other things like photovoltaics, thermostats, and etc. That first piece there, describing the building assemblies that make up the thermal boundary, it's not a small effort. The rater basically needs to take a look at the builder's plans, or the architect's plans, which are two-dimensional typically, and they need to be able to describe each of those assemblies in the software dimensionally, as well as kind of what materials make up the assembly. And I've shown a screenshot here from a program called Sketchup. This is just an example. It's pretty common that energy raters use that to create a three-dimensional model of the home. It helps them visualize. It helps make sure that they haven't forgotten something they need to describe. And with some little scripts, this can do the calculations for surface area and perimeters and things like that pretty quickly. So this is a common way that energy raters do what you would call takeoffs for entry into their energy modeling software. So next we're going to go through an example energy model. And in this particular case, I've just borrowed one from a friend of mine. He happens to be an energy rater, was a former colleague of mine in Colorado, and then started his own company in North Carolina. So the specifications you're going to see here are for a home on the coast of North Carolina, and not necessarily representative of what you would build with, but just to give you an idea of the steps that an energy rater would take when they approach the model. You'll note that here in this particular view, he's got the whole bottom right section of his screen is taken up by what's called a component library. This is Ecotrope's software interface, by the way, and similar to the other two accredited softwares, they allow the user to store a library of different commonly used energy components. So for example, if there's a particular carrier furnace or carrier air conditioner that is common for this rater to use there in North Carolina, he might store that in a library so that, you know, once he enters the specifications for it, it has these many BTUs, it's this AFUE, etc., then he doesn't have to describe all those every time he does another energy rating that uses that. He can just go into his library and select it from the library. So, you know, for brand new energy raters, there's a lot of this to build. And over time, your library can include hundreds and hundreds of different individual energy specifications, from windows to space heating and cooling to different types of wall assemblies with different R values, etc. There's a fair amount of work that would go into the front end, and hopefully, you know, having that done, they can work through an energy model a little more quickly. In this particular view, we're just sort of looking at a summary of this project. He's got the energy model, which we'll dive into in a little bit, and then some overarching project information that I'll show you here first. So in his project information screen, he can describe, there's 3 tabs here at the top. He can describe some basics about the site. Where is it located, so that the software understands the climate that it should model. You know, how much sun exposure are we going to have here on this particular house, and what the seasonal weather is going to be like. Who the builder was, who the energy rater was, what the date of this energy rating, all those kinds of things go into the basic. And I've kind of highlighted this 3rd tab, which is utility rates. So he can actually go in here and enter the specific electric rates or natural gas rates or propane rates that are used in this particular region. I'll show you a detailed version of that. On the electric side, he can enter different tiers. In this particular case, it looks like they've got 1 kilowatt hour rate for a certain time of year. Months 1 through 6 and months 11 through 12 use this rate, and then months 7 through 10 use a different rate. And you know how utility providers are, they oftentimes will have monthly service charges and all kinds of different things, and the way they bill you can be rather complicated. But this allows the rater to enter the actual utility data if they can obtain it, and that will do a little bit better job of predicting the energy use in dollars that you might see on our summary report at the end. But frankly, none of these costs actually are considered in the HERZ Index score. It's not a dollar value evaluation. It's basically just evaluating energy using BTUs. So once you're inside the energy model, and this is Ecotrope, there's a bunch of different tabs across the top of the screen. We're going to kind of give you an overview of what's inside each of these tabs. The first one is just basic general information. Once the rater has created, and I showed you that example of the 3-dimensional model created from Sketchup, you could also use spreadsheet calculators or, you know, any number of different takeoff methods. But at the end of the day, that needs to get done before the rater is actually ready to work in the energy model, because as you can see, even right off the bat here, we need to know the conditioned floor area, the conditioned volume in cubic feet. We're going to have to reference the plan for the number of bedrooms, how many floors are on or above grade, what type of structure is this? Is it detached or is it an attached home? Is it an apartment on the 2nd floor, etc. In the second screen, this is going to be a little bit small, so I apologize if you can't see all of what I'm showing here, but I don't think that the details will be too important. Mostly I just want you to get the overview of what goes into the energy model. In this particular case, we're describing the building envelope, or the the assemblies that make up the boundary between inside and outside. So for this home, that's a slab floor that doesn't have a basement or foundation walls. It has a floor over the garage. So they've got, oftentimes in the Carolinas, they create these bonus spaces over an attached garage. So he's got to model the floor underneath that as one of the boundaries between inside and outside. And he's got several different wall assemblies broken out because some of the energy modeling will be different. The temperature difference between the house and the garage is different than the temperature difference between the house and an attic knee wall. So he's describing those things separately. And I've just blown this up. This is kind of the details behind one of the above grade walls. As I said, he's got an entire library of these things, so he was able to probably just select it. But if the builder's doing something unique and he didn't already have this in his library, he's going to go in here and describe this entire assembly. You can see there's a cross section in that view there. And what I've highlighted to the right is the layer that would be the in between the studs. So this is a stick frame wall with 3.5 inch deep studs. So it's basically 2x4 construction out there in Carolinas, coastal Carolina, pretty warm climate. And he's got grade 2 insulation, and it's an R15 product that's in between the studs. But we have to tell the software not only about the R15, but also about the rest of the assembly, because there's different parallel heat paths that heat would have to take. You know, in this cross-sectional view, you can kind of imagine it. From the exterior, you have siding, perhaps a building paper or OSB, maybe an air layer or an exterior insulation layer, and then the stick framed wall, which it cross-sectionally is either the heat is going across the fiberglass batt insulation, or it's going across the 2x4 studs. And then on the interior, you have a drywall layer. So all of that kind of has to be described just to have this one library item that he could pick from his list. And if anything about this changes, if it's grade 1 insulation, he's going to have a separate library created for that. And so we'll do the same thing for each of these. So the slab has details behind it, you know, whether it's insulated or not, and those kinds of things. The floor, same thing. This particular home, I didn't show the rim joist, but there's rim joists to model, or you might call that the band joist between floors for platform framing. At least this is not a balloon framed home. And your homes up in Summit County, some of them are going to have basements or crawl spaces, so they'd be describing the foundation walls, the slab floor that's, you know, at the bottom of your basement, or dirt floor in the case of a crawl space. If the crawl space is not conditioned, then the boundary becomes the floor over the crawl space, and that gets modeled. So all of this is stuff that the Energy Rater is deriving from the set of plans, and potentially, you know, when it comes to the insulation package, it might be a separate spec sheet or something that the builder is providing to the Energy Rater to help them understand at least what their preliminary plan is for the energy package. The next slide I'm showing here is fenestration, which includes windows, doors, and skylights. And the Energy Rater will have to describe each window and each door in terms of its area, its energy specifications. In the case of doors, we talk about them in terms of R value. In the case of windows, we talk about them in terms of U value and solar heat gain. But windows are a little unique in that we also need to know what direction they face. The software will be able to model the solar, the direct solar incidence depending on the season. So we also need to be able to describe overhangs and things that might shade that window that would prevent the sun from actually striking the window, and that changes how much heat gain you might have. Next, we're moving on to mechanical systems, and this is one of those places where you've got some choices to make as your builder. As the builder, you You have certain packages that your HVAC contractors might offer you, but maybe you're hearing from the energy rater about potentially wanting to see some upgrades or higher efficiencies in order to meet your goals, your requirements for code. In this particular case, they're using an air source heat pump. So the rater is describing the air source heat pump, and there's a library for that. So there's information behind the scenes about that heat pump, as well as his, he's got 2 of them here for this house. And then he's also got a domestic hot water. Looks like it's a 50-gallon storage water heater. And then distribution systems for the space heating and cooling are described here, including the duct leakage to outside, which is a minimum rated feature that has to be modeled. So that's a test that has to get done. If this is a preliminary rating, then he's not using an actual test, he's using something projected. So he might be using kind of the minimum duct leakage to outside that's necessary to pass code in this case. Distribution systems for domestic hot water on the next slide I'll show you here in a second. This is a little close-up view of the air source heat pump library that he's describing. It's looks like it's 18,000 BTU or 1.5 ton, 15 SEER, and 8.5 HSPF on the heating efficiency side. By the way, you guys, I don't know if you're seeing very many of them, but heat pumps used to be a thing that you would only see in a place like this. And this home is in the Southeast in Wilmington, North Carolina. But these days, air source heat pump technology has gotten a lot better, and they can actually take heat out of much colder air. So they're even being installed in climates like in Summit County. And as more and more folks are trying to get away from fossil fuels and using more sustainable energy sources like wind energy or solar energy, that is creating a trend towards electric space heating and cooling. And that's one of the reasons why you see more and more heat pumps being installed in new homes. And it really helps that they're capable of being efficient even in colder weather. As I said, there's the water distribution that the rater has to describe here. These are kind of newer in the last few years. They weren't part of our energy rating system in the years when I was a rater. But nowadays, the rater has to do a quick evaluation of the fixture types. If they're anything special, if they're just standard, we can use the defaults. But if they're something better than standard, if you're using low flow fixtures, then that can be accounted for, and the software essentially will show some benefit to the HERZ index, because using lower flow fixtures will reduce the amount of work that your water heater has to go through. And so it will model as a lower water heater usage if you've got more efficient fixtures. Also, you can be more efficient by reducing the pipe length. So if you centrally locate your water heater on the, if the architect gives you a pretty good central space for water heating appliance, then each of the runs is pretty short. And the shorter the runs are, then the less waste heat you might have through the pipe. Next, we're moving on to lights and appliances. So this is kind of, I don't want to call it a catch-all screen, but it's catching a lot of the other details that we haven't already picked up when we're describing the envelope and the mechanical systems. So this is where our kitchen appliances, the refrigerator is considered, the dishwasher is considered, at least the fuel type of the range or oven, and whether it's convection or not, those are considered. And then laundry appliances are considered washer and dryer. You might be asking yourself, how does the software know how much the homeowner is going to use one of these appliances? How do we model the energy use for a clothes dryer, for example? Well, these are based on formulas that are part of our standard. Remember, I said we've got a national standard now, RESNET ANSI 301, is the standard for how software is to calculate an energy rating index nationally, not just for RESNET. And there's formulas built in there, and those formulas will include a means to basically take the size of the house, the fuel type of the dryer, the efficiency of the washing machine, so how dry the clothes are going to be when they get to the dryer. And it's going to determine the number of loads that get washed across a course of a year by occupancy, and it's deriving occupancy from the number of bedrooms. So a lot of this stuff is very standardized, the usage that gets modeled, and that's important to keep in mind, because as a consumer, if this were your home, you are probably going to experience something very different than the modeled energy use across a year, because it's using very generic built-in assumptions about how many people will live in this home, how many loads of laundry are they going to do, how long are they going to leave the lights on, how many loads of dishes are they going to wash every day. All of that stuff is very standardized, and that's intentional because we're talking about an asset rating. We're trying to evaluate this home in comparison to other homes that might be on the market, or other homes that a consumer might be able to purchase, or in the case of a lender, maybe is this home more or less efficient than the average home, so they can determine if they should consider that in their loan. So all of this is basically for relative comparison, and that's just worth keeping in mind when you see those dollars that are predicted for energy savings. It really is, it's hard to correlate that to how somebody's going to actually use their home. It'd be kind of like saying the EPA miles per gallon on your work truck were probably not the same as your actual experience driving that truck, because you might have a lead foot, whereas the next guy might be driving very carefully, or you might be hauling heavy loads where the next person, is only driving it to the bank or something. But as a consumer that EPA miles per gallon is useful because it gives you something relative for comparing one truck to another. And energy efficiency and fuel economy is something that consumers are conscious of, and it matters to their bottom line at the end of the day. So that's the best analogy I can use for the energy rating index and how to think about the dollar savings that you might see on the certificate that we'll show you here at the end. Infiltration, that's the air leakage or blower door test that your rater is going to perform. Again, in this case, I think this is a completed home, so this is his actual test. 2,675 cubic feet of air per minute is what he was able to measure with the blower door test at a standard pressure. And the energy rater will perform that test at final once the home is, basically finished and it's as airtight as it's going to get. And by the way, this is a pretty important thing for the software model to predict energy use. If we've got a very drafty home, it doesn't matter if you've got, a really great R value in your attic and your walls. If you're exchanging a lot of air with the outside because your house is just super drafty, then the means of heat transfer, heat is hitching a ride on that air that gets in from the outdoors, rather than trying to slowly move through your wall through conduction. And so you probably will see energy raters paying really close attention to the air sealing details at the pre-drywall stage, because they're trying to help make sure this number is as low as possible. This is one of the things that you could really have some control of if you have really good attention to detail, or your insulator, your contractor is really experienced and knows how to get this right. You can definitely have a pretty good positive impact on your ultimate HERZ Index score at the end of the day, and certainly at the comfort of your homeowners too. Next is on-site generation. If you've got photovoltaics, which more and more homes have, new homes as a percentage, I don't know what it is off the top of my head, but with some of the production builders, the big box builders nationally incorporating photovoltaics just as a standard, we're seeing a pretty high percentage of homes now start off with at least a small PV package. In this particular case, this is This is a new home, but it came with a small PV system, so the rater has some information that they have to gather about it, the efficiency of the inverter, the area of the array, that kind of thing, the overall output. And then we're getting towards the end here. One of the last tabs, the rater might be using this to do more than just generate a HERZ index score. They might be trying to show compliance with an IECC code path or with an above code program like Energy Star or Zero Energy Ready. And in that case, there might be some other mandatory items that the software didn't give inputs for. So the rater may also need to attest here that they've done these additional inspections and they're verifying that, you know, Energy Star compliance was met. In this particular case, this rating is just for code, it looks like, and he's checked off boxes for IECC compliance and he's left these other ones blank, basically because his builder is not participating in these programs and doesn't need to show compliance with it. If he did, and in your cases, you could probably expect to see this Zero Energy Ready section filled out so that at the end here, we're able to get compliance reports for that program in addition to our regular home energy rating certificate. This is just an example of the, or it's kind of a list of all the different built-in reports that Ecotrope has in their software. So besides being able to generate a HERZ index score, you could generate any of these different reports. I happen to select a few of them just for our example here. So I asked it to get me the home energy rating certificate, the HERZ reference summary. That's kind of an unusual one for a real world scenario, but for our discussion, I think this report was going to be helpful. So I selected it, and then you could get Zero Energy Ready compliance certificates. You notice a lot of this stuff is state specific. So if you have a state specific code program, you could engage with these folks and ask them to create a custom report for your particular code or utility program. So here's the home energy rating certificate. There's some summary data on here. We put a lot more information into the model than could possibly be displayed on one page, but you've got your HERZ index score, a predicted annual savings relative to an average US home, of course, some estimated energy use and dollar costs associated with those things, and then a home feature summary. Again, this is not a comprehensive list of all the energy features that are accounted for in the HERZ index calculation, but just kind of a high level summary of the big ones. So you get 2 air source heat pumps along with their efficiencies, the number of bedrooms, the conditioned square footage, the ceiling R value, above grade R value. So there, at least some of the big summary items are listed on here. And then of course, typically the rater would sign this. I printed this report, so he hasn't signed it yet, of course. And I just wanted to come back to this slide. I promised I would, but remember that these things that we're looking at here, this is the software's evaluation of this home based on the characteristics that we entered, but in comparison to a reference home. So the reference home is something automatically generated by the software that's establishing a baseline for comparison to our rated home. So it's going to be located, let's say in Summit County, if that's where we locate it. It's going to have the same physical dimensions as the rated home, but it's going to be using energy specifications that are equivalent to the 2006 IECC. So you might build a home in Summit County that is using, let's say, R20 blown cellulose in a 2x6 wall, but that exceeds the requirement of the 2006 IECC probably for your climate zone, and so you'd be able to be a little bit more efficient than the reference home. and so on. So as you go through all the different energy features that I showed that are accounted for in the model, some of them you might be a little less efficient, hopefully on par. You're mostly more efficient than the comparison home. To the degree that you are more efficient than this reference home, then you'll see that your HERZ index score is lower than 100. If you happen to score 100, then basically you've built a home that is just as efficient as the 2006 IECC. Well, that's not a very good new home today. That might be fine if you're talking about older housing stock, but new homes, typically you're going to see them scoring on average in the 60s across the US. In Summit County, because you guys have adopted an above code program, I would assume that your average HERZ index score is substantially better than 60, probably well into the lower 50s or better than that. And remember, our rated home is the as-built home. Those are the components that are entered by the rater. Each of those components that's more efficient than the reference home is contributing to a lower and lower HERZ index score. Unless you have certain things that are less efficient than the reference home, and you might. Maybe you've got a piece of stained glass because the home buyer wanted this decorative glass window on one side, and it might happen to be less efficient than the reference home's windows, or facing an orientation because that's their view. They'd like to see, their mountain view, and so they put all the window facing west. Well, the reference home is going to have its windows basically are sort of predetermined to be distributed evenly across the 4 cardinal directions, north, south, east, and west. So even if you built a code home using the exact same specifications that are in the 2006 IECC, if you just put all your windows on one side for the view, you might compare less favorably because that particular orientation may be a little bit worse energy-wise than if you had split it up differently across the 4 cardinal directions. It's an interesting thing, this comparison, because what it means is that it feels like on the back end as the builder, you can make certain design decisions, or you can make certain energy specification packages decisions that aren't always necessarily intuitive. Why is my rater asking me to make certain changes so I can get below a HERZ index target to meet code? And this is what they're doing. They're trying to figure out which are the most cost-effective things that you could change to your home design so you can meet a HERZ index goal and ultimately pass code. This is not a report that I'm showing here that I ever gave to a client, but I'm showing it to you here just kind of to get an idea. This is a report that tells us what the software has created for its reference home. So I know what I described here for the rated home, but the reference home is being automatically generated by the software. And if I want to see what home I'm being compared to, I can get this report and look at some details about the reference home. So it's still a 5-bedroom home with 3 floors above grade. It's still 3,157 square feet. All of this is the same as my rated home with an attached garage. My volume is the same. So dimensionally, it's pretty much exactly the same as my rated home. But then as I start looking down at some of the energy specifications, those are going to line up with the 2006 IECC for your climate zone and not necessarily be the same as the rated home. Let's get a little bit further down the report. So for example, here's where our windows are. These are split up with 142 square feet on each wall, north, south, east, and west, with 0 overhangs. And that's not the same as our rated home. So this is a place where we might be better or worse than the reference home, depending on where our windows were. And of course, the effective R value, or as we described it, the U value, is different in the reference than it would have been in our rated home. Just one more example here. We made some design decisions here for our new home. It's got an air source heat pump. And that's not necessarily the minimum efficiency air source heat pump that was established in 2006. So the minimum federal efficiency is what it's using here, I believe 7.7 HSPF for an air source heat pump, whereas our rated home was more efficient than that. So in that case, we've got a HERZ Index score that's lower than the reference home. Similar kind of thing for clothes dryer, clothes washer, unless we just happen to use defaults. Sometimes these are not installed, and so the rater will just leave the defaults in place. And the defaults should not help or hurt the energy score, because if they're not installed, we shouldn't be giving credit for them being better than the reference home, but they're also, there's no reason to assume they're worse than the reference home. So we just, in those cases, as raters, we would choose defaults, and then that matches our rated home's clothes dryer efficiency with the HERZ reference home. So it's basically a wash. We don't get any credit, we don't get any penalty for items like this that just maybe aren't provided, and the homeowner is going to provide their own. Last, I thought I'd just show you an example of the Zero Energy Ready Home program. This software is capable of producing a certificate showing whether or not the home passes. In this case, it doesn't pass. Of course, it wasn't, this was just a code-built home out in North Carolina, and they weren't trying to reach the Zero Energy Ready Home program. But when I tried to print out a report, sure enough, it says this home doesn't pass. If you get to that point in your projected rating, you'll probably be hearing from your energy rater. If this is your goal, if you're trying to comply with Zero Energy Ready, then your energy rater does a preliminary model and finds out, hey, the home that you plan to build with the specifications that you've given me, it's not going to make it. That's a place where you can kind of go back and have some discussion and some consultation about what kinds of things you might be willing to change in terms of the energy package of this home that might help. It's a little tougher to, especially if you got a custom home with clients, tougher to get them to compromise on something like windows. Oftentimes your windows are probably, maximizing the view. It's the whole reason they bought this property and why they want to live here in Summit County. So it might be a little tougher sometimes to compromise on windows, even though that might be the easiest way for the rater to make up some difference in the model. So maybe there's some other things in the design components, the specifications, your window efficiency package. Maybe you can buy more efficient windows, or add some attic insulation, or whatever changes your energy rater is suggesting. So that's a collaborative effort. Typically, it's not necessarily good news to find out you're not going to pass, but you want to find that out at the preliminary stage before you've even broke ground. And that's why it's really important to engage with the energy rater at the front end of your project and give them, the architectural drawings and the specifications you plan on using, and find out if you're on pace to meet the goal. And then their job is a little easier. Then all they've got to do is go out, perform the pre-drywall inspection to verify that you actually got what you paid for from your energy package, etc., and perform the final inspection and just verify that the house turned out airtight as you expected. So the energy modeling example that I showed you, I pulled that DOE Zero Energy certificate, and then I also pulled a target home summary. I'm not sure if your raters would necessarily provide this report, but there's also kind of a summary of Zero Energy Ready requirements and how the home stacks up against those. So you could be receiving such a report at final. And with that, I think I'll wrap up and turn it over for questions. I'll just leave my contact information up on the screen. And Jess, I think I'll turn it back to you, and let me know what sort of questions we have in the chat. Matt Wright is with us, one of your local energy raters with lots of expertise on this topic, and especially on the Zero Energy Ready program topic. So Matt will be there to help me answer questions.
Yes, we had a question from Kevin, and he asked if you could talk a little bit more about the grading of insulation. And Kevin, I'm going to unmute you in case there's anything you want to add.
No, I wanted Scott or Matt to address convective air currents and why full cavity insulation is really important.
Sure, I can take a stab at that. You're really just, this is a physics question. If you've got energy moving around, heat energy, it can move around through conduction, and that's basically heat moving through solid objects. That's, you touch a hot frying pan, you've just conducted heat. It can move through convection, which is basically air moving the heat around. And you're pretty familiar with that. If you stand over your grill, and you can just sort of feel the heat coming up off of it, it's heating the air. And you see your curtains move, in the wintertime, even though the heat's not on, there's no air blowing around, but you've got a temperature difference in the air top to bottom that's sort of causing your curtains to blow. That's convection. And then you've got you've got radiation, which is, you're standing around the campfire and you're 3 feet back from the fire, you can really feel the heat from that fire warming you up. And as soon as somebody steps between you and the fire, well, that jerk just took your heat away, because now you've lost your line of sight, and the heat that's radiating away from that fire needs that direct line of sight to go from one object to another. Well, so we've got all of those modes of heat transfer happening in our buildings and in our building assemblies. But if you have a wall cavity that is not filled with insulation, if you were to just say have an empty 2x6 wall cavity, yeah, you can radiate heat from the outside surface, let's say that's OSB sheathing, to the inside drywall surface. But more importantly, you've left a lot of room for air to be able to flow, and convection turns out to be one of the more efficient ways of moving heat around. So if you can fill the cavity with insulation at its proper density, you can really retard the airflow so that it can't move heat from that outside cold surface as the air passes the outside drywall or outside OSB surface. It doesn't give up a bunch of heat to it and then cool and sink down to the bottom of the cavity, and then move heat to the drywall surface. And convection in empty building cavities is one of those reasons why old buildings built in the 1800s are so inefficient, so uncomfortable, and cost so much money to heat and cool.
Okay, so another question came in through the chat. Sorry, I got to get my different windows open. So is the HERZ rating mandatory in our area, or is it a bonus that can put us above competition?
Matt, I'm going to punt that one to you. You're the expert on Summit County.
Yeah, it is a mandatory item if you are building in Summit County, Breckenridge, or Frisco. Currently, Silverthorne and Blue River are not on the Zero Energy Ready Homes program. This used to be a selling point for our services in the past. Was this is a way to distinguish yourself, show how your home is different than the home next door. But now it is a tool to show compliance with the energy code. And again, the energy code was adopted because of our goals to be about 10% more efficient than the most recent code that we adopted, so we could meet our climate action goals.
Matt, someone could build prescriptively if they chose to, but there are rules around what homes can follow the prescriptive path.
Yeah, that's correct. There is a prescriptive path in the Zero Energy Ready Homes program. The one thing that we run into with that program is there's a size maximum. So I believe it's 3 bedrooms is 2,400 square feet. So if you're over 2,400 square feet with a 3-bedroom, the program automatically pushes you into the performance path, and you have to go down the energy modeling and using the HERZ Index score.
Thank you. Any other questions for Scott or Matt? You can type them in the Q&A, type them in the chat, or you can raise your hand and I will unmute you.
Scott, I got one for you. You mentioned, some of the assumptions in the modeling software and just about how people live in their homes, and that, we have to make some assumptions. Have there been any studies done on the accuracy of the HERZ rating itself and the outputs and the projected energy use?
Yeah, there have been studies done. I think it was Michael Blasnick did a big study using homes in Texas, and there's been a few others. I'd say we're probably due for another study. It's tricky to get utility data from homeowners. People are very sensitive about that as a personal privacy issue, and utility providers are aware of that, and so they're not really very giving when it comes to giving up the utility data. But I would love to have my hands on it, and or just get somebody else to perform a new study based on the most recent standards that we have, the newest and best calculations that we have for software, and see how close we are to reflecting reality in the way people use their homes. As you guys know, and I experienced myself, the way we use our home even today is different than 2 years ago. How many people have home offices now that didn't used to? How many people are doing in-home schooling that didn't used to? You've got your home occupied, lights on, using energy in the middle of the day, where as more and more people used to be out of their home, and the home sort of just sat empty until folks got home from home and school. So I think our usages are changing, and it's probably time for a new study.
Okay, I just had another question come in. Are the HERZ raters mainly a third party, or should builders have a HERZ rater in-house that could do it?
Yeah, that's a good question. Almost 100% of the time, the HERZ rater is third party. Years ago, there used to be a few builder representatives that had their own in-house HERZ rater, and then that a lot of times that called into question whether or not they were truly providing independent and accurate information, especially when our stakeholders started to become code officials or started to become lenders. There's more and more money, like with 45L, it's a builder tax credit involved. It's really kind of pushed us away from that model to where the HERZ rater tends to need to be third party.
That is something that we discussed in the Summit Sustainable Building Code Committee as well. There are some pathways through the RESNET standards that allow like a builder, an insulator, to be the HERZ rater on record. But we discussed not allowing that as a community to make sure that you do have that true third party, that there is a lot less chance of someone skewing the numbers because they have a financial interest in the outcome of the building.
Okay, anyone else have a question to ask either Scott or Matt about the energy models? Again, you can type it in or raise your hand and I'll unmute you. Okay. Seeing none. So in that case, we can wrap up a little bit early and give you 15 minutes back to your day. But if any questions do come up, Scott does have his email here. Please feel free to reach out, or you can always email me. My email is in the chat as well. I didn't put Matt's email in the chat. Matt, if you want to put that in there. I can't answer your questions, but I can pass them along to the right person. And we'll make sure that you get your questions answered. I want to thank you again for your time today. And as a reminder, we do have 2 more workshops coming up. Again, February 3rd, we're going to be talking about HRVs and ERVs and why you might want to consider them in your building. And then on March 30th, we're doing a deep dive into continuous insulation. And as I mentioned at the beginning of this webinar, February 3rd likely will be another virtual webinar. So I will change the invitation if you have registered for that webinar to make sure that you all know what the Zoom link is and how to join. So want to thank Scott so much for your time today and really helping us to understand how those models are created. Thanks, Matt, for helping to answer questions. And thanks again to all of you for tuning in. We really appreciate it. Okay. And I am going to end the webinar. Thanks all. I'll be sending out the slides and the recording.